In the last video, we symbolized the argument. Jasmine must either go to work or find a substitute. She can't go to work today, therefore she must find a substitute. In symbols, we found that for appropriate choices of simple statements, the form of this argument is P or Q, not P, therefore Q. In order to analyze this argument, we'll create a truth table showing each premise and the conclusion. In this entire argument, there are two simple statements. And so our truth table will have 2 to the second power, or 4 rows. Remember, every time we add a simple statement, we double the length of the truth table. So here we have a truth table for 2 simple statements. Notice our Q statement, the truth values alternate true, false, true, false. And then our P statement, we have 2 trues, 2 falses. That's going to give us every possible combination of true or false. And then for the columns of our truth table, well, we have P or Q. There aren't any multiple steps in symbolizing that. That's just a single compound, so we can just make that column. We'll have a not P column. That's another one of the statements in our argument. And then our conclusion is Q. And we already have a Q column, but just to help us see what we're analyzing, I'm going to make another copy of that column for my conclusion. So let's compute the truth values now that go in this table. We have an OR. Remember, OR is true so long as one of the statements that we're ORing together is true. It's only false when they're both false. So we have true or true, that's true. True or false, that's true. False or true, that's true. False or false, that's the only time that our OR statement is false. How about not P? Well, not P has the opposite truth value from P. So I'm focused only on the P column now. When P is true, not P is false. When we have a true, we do not to that and get false. We have a false, do not to that and get true. False, not to that gives us true. And then our conclusion, we just want a copy of the Q column. So Q goes true, false, true, false. And you wouldn't have to make that copy. I'm putting it there so that we can more easily see what we're doing. Okay, so now we have a truth table for all of the statements in our argument. How can we use those in order to analyze the argument? If an argument is valid, that means that the conclusion must be true whenever all the premises are true. So to determine whether the argument is valid, we look at each of the rows where the premises are true, and we make sure that the conclusion is also true in those rows. In the first row, where P is true and Q is true, well, in this row, we see that our second premise, not P, is false. Since one of our premises is false, well, this row cannot tell us that the argument is invalid. Okay, looking at the next row of the truth table, where P is true and Q is false, well, we see again that the second premise is false. So when at least one of the premises are false, the conclusion can do whatever. So this row again, it's okay for a valid argument. All right, In the third row, where P is false and Q is true, well, here we see that both of the premises are true. Okay, in a valid argument, when we see that all the premises are true, we expect to see that the conclusion is also true. And in this row, that is what we see. So this argument is doing exactly what we want a valid argument to do in this row. All the premises are true, the conclusion is also true. So that row is very good for this argument being valid. And then let's take a look at this fourth row. In the fourth row, where P and Q are both false, well, in that row we see that the first premise is false. So when at least one of the premises are false, the conclusion can do whatever. It doesn't hurt the argument being valid. So again, this row is okay to have in a valid argument. We checked all of the rows, and none of them cause any problems for the validity of this argument. Whenever the premises are true, the conclusion is also true. And therefore, since the conclusion is true whenever the premises are true, the argument is valid. So that's what we do with a truth table when we want to analyze an argument for validity. We go through and look at each row. If we find a row in which the premises are all true, we need to confirm that the conclusion is also true. If that happens in every row where the premises are all true, then the argument is in fact valid.